Hey guys, in this lesson, we're going to learn the three forms of quadratic equations and how each provides a quick key feature to the parabola. We're going to learn how to convert from one form to the next. So let's get started. So here are the three different forms for quadratic equations, and they each offer a key feature. We have standard form, which we've been working with, ax squared plus bx plus c. We have factor form, which we've also been familiar with, where we factor our quadratic. We have a times x minus p times x minus q. And we have vertex form, a times x minus h quantity squared plus k. So the question up top says, what do they all have in common? And you can see they all have the a value, and the a value is at the beginning of each equation. So let's talk about what the a value indicates. First of all, it tells us the direction of the parabola. So if it is positive, if a is a positive value, our parabola turns up. If a is negative, our parabola turns down. It also tells us the dilation of our parabola, meaning it will tell us if our parabola is wide or narrow. Now let's take a look at what each form offers. So for standard form, the c value is actually your y-intercept, because if you plug in 0 for x, you end up with the value c. So with standard form, you can easily identify the y-intercept. For factor form, you can easily identify the roots. Remember, you said each factor equal to 0. So this is when we have x minus p and x minus q. When we set those equal to 0 and bring it across the equal sign, we get the two roots. So factor form gives us our roots. Vertex form, and you can tell in the name, provides the vertex. So vertex form, we have h comma k. So the h is your x value of your vertex, and the k value is your y. So let's take a look at a few equations, quadratic equations, and determine the direction of the parabola and the key feature. So number one is in standard form, our parabola is turning down, and we know the y-intercept is 0, 6. In factor form, our a value is positive, and so our parabola turns up. We have our factors, so if we set these equal to 0, then we know the roots. So the roots are, from least to greatest, -1 and 5. Now let's go back and talk about the width. So when you're looking at the a value and you're just looking at the absolute value of it, the negative told us it turned down. The 2 is going to tell us that it is a stretch, it becomes more narrow. So this parabola turns down and is a stretch. Number 2, our parabola turns up, and again, our a value is more than 1, So we have a more narrow parabola, and we call it a vertical stretch, just like with our exponential transformations. Number 3 is in vertex form. So our vertex for this parabola is -2, -4. If you noticed in our formula, it was x minus h, so it's the opposite of what we intuitively think. Now, let's take a look at the a value. Our a value is positive, so it turns up, but it's between 0 and 1. The absolute value of it is between 0 and 1, so it is a compression, meaning our parabola is a little bit wider than the parent function. Number 4, vertex form again. So our vertex is going to be 6, 2. Our a value is negative, so it's going to turn down. And the absolute value of a is between 0 and 1, meaning it's going to be a compression. So it turns down, and it's going to be a little bit more wider than the parent function. Number 5, this is factored form, so we know our roots. -8, 4. Our a value is negative, so it's going to turn down. The absolute value is more than 1, so it's going to be a stretch. Number 6 is in standard form, so we know the y-intercept, 0, -8. Our a value is positive, so it's going to turn up. And the absolute value is between 0 and 1, so it's going to be a compression and become a little wider than the parent function, which is when a is 1. Okay, now let's get into the actual conversion. So we're going to take a look at standard form, and if we're asked to convert it to factored form, this simply just goes back to our lesson of how to factor a quadratic. Now remember, the a value is the same in all 3 forms. So our a value in standard form is 1, so our a value in factored form is going to be 1 as well. So let's use our graphic organizer, a times c, and then our b value. So what 2 values multiply to give you 42, but add up to give you -13. So I believe that's going to be -6 and -7. Gives us a positive product and a negative sum. So factored form, our a value is 1, just like in standard form, but we don't need to write it. And so we have x minus 6 and x minus 7. Our roots would be 6 and 7. Let's try another one. This time our a value is 2, so we will have a 2 out front in factored form as well. We're going to factor out the 2. It's a GCF. I'm going to use the graphic organizer. So our a now is 1 times 21. And then we have -10 for our b value. Looks like that's going to be -7 and -3. So we will have f of x equals our a value of 2, x minus 7 times x minus 3. Our 2 roots would be 7 and 3. Okay, now let's go from factored to standard. Very easy, guys. Again, we notice our a value is 2, so the a value in standard form will also be 2. So all we're doing here is going back to the beginning of the year in Unit 1, and we're just multiplying these 3 factors. So you could multiply 2 times the first binomial, and then multiply that binomial times the second one, or the 2 binomials together first. It doesn't matter. I'm just going to go ahead and distribute 2 to the first binomial. And now I have to multiply it by x plus 1. So this gives us 2x squared plus 2x minus 6x minus 6. And then when we combine the linear terms, we have 2x squared minus 4x minus 6. And our y-intercept would be 0, negative 6. Our two roots are going to be negative 1 and positive 3. And again, notice our a value is 2. It's positive and it would turn up. Let's do one more. Again, we're just going to multiply. So I think this time, because my a value is a fraction, so it's negative 1/2, I'm going to go ahead and multiply my two binomials first. So we get x squared minus 2x plus 8x minus 16. Combine the middle terms. And now we can distribute the negative 1/2. So standard form tells us we have negative 1/2 times x squared. Negative 1/2 times 6x is going to be negative 3x. And then negative 1/2 times negative 16 is going to be positive 8. So our y-intercept is 0, 8. Our two factors are negative 8 and positive 2. Now let's go to standard to vertex. So you could do a version of completing the square, but I think it's easier if we just go back and identify the vertex. Remember the formula to identify the vertex is negative b over 2a. That gives you your x value of the vertex. Then once you get that value, plug it into the function, to the equation to get the output. So once we have the vertex, this will be the h and the k value from our equation. So our a value in standard form is 1, so our a value will remain 1. We can see that the y-intercept is 0, 12. So let's find the x value of our vertex. Negative b over 2 times a. This gives us negative 4. So our vertex, the x value is the h in our vertex form formula. Now let's find the k value. We're going to plug it into the equation. Negative 4 squared plus 8 times negative 4 plus 12. Order of operations, we're going to square the negative 4, multiply, and then combine. So the two positive numbers gives us 28 and then minus 32. So we get negative 4. So this is our h and our k value. We know a is 1, so no need to write it. And the formula is x minus the h value. So we're going to have x minus negative 4, so it's really x plus 4, quantity squared, minus 4. And that is vertex form. Let's try another one. This time, our a value is negative 1, so we will have a negative 1 here in vertex form. So we're just going to, again, find the vertex with negative b over 2a, and then plug it in to get the output. So our vertex is h, k. The formula is negative b over 2 times a. We get 3. So h is 3. We're going to plug it in. So we have negative from the equation. 3 is the x value. Order of operations, square the 3 first. That gives us 9 times negative, so that's negative 9 plus 18 minus 8. The two negative values gives us negative 17 plus 18. This gives us 1. So Here we go. F of x equals, our a value is negative because it's negative in standard form. We have x minus 3 quantity squared plus 1. Now we're going from vertex to standard, and all this is order of operations. Our a value is 1/2, so we will have a 1/2 out front. So let's talk through this. So our order of operations is we have exponents. So that's the first thing we're going to do. So we will multiply this binomial by itself. Once we get all that multiplied, then we will multiply by 1/2. And then we will add lastly. I am going to use grouping symbols for this. So I have 1/2 times x minus 4 times x minus 4, and then plus 10. This is going to remind me, do not add in the 10 until the very end. X squared minus 4x minus 4x plus 16. We're going to combine our linear terms. Okay, now I'm going to distribute this 1/2 to this trinomial, and then at the end I will add in 10. So I have 1/2 x squared minus 1/2 times the negative 8x gives us negative 4x. 1/2 times positive 16 is plus 8, and now I can just write plus 10. So the final result is 1/2 x squared minus 4x plus 18. And we would see our y-intercept here. And our vertex would be 4, 10. And our y-intercept is 0, 18. So always noticing those key features from each form. Let's do another from vertex to standard. Again, order of operations. I encourage you to use grouping symbols. So we have x plus 6 times x plus 6 minus 8. So we are going to do our exponents by multiplying this binomial. Then we will multiply by the negative 1, and then we will add in the negative 8 last. We have x squared plus 6x plus 6x plus 36. We will combine the middle terms. We have our perfect square trinomial right there. Now, when I distribute this understood negative 1, it only goes to this trinomial. I have negative x squared minus 12x minus 36, and then the minus 8. So our final answer in standard form is negative x squared minus 12x minus 44. Notice my a value is negative 1, just like it was in vertex form. My vertex would be negative 6, negative 8. My y-intercept would be 0, negative 44. Our parabola turns down, so this tells us a lot of what the parabola would look like without graphing. Now we're going from factor to vertex. Again, just order of operations. We're going to just multiply these to get it in standard form. Then we have to find the vertex and put it in vertex form. So you can't go directly from factor to vertex. So in between, we must go to standard first. So this one takes just a little bit. So I'm going to multiply first the two binomials. Since I have an a that is a fraction, we get x squared plus 8x plus 6x plus 48. We combine our linear terms. Then I'm going to distribute the 1/2. Now we are going to find the vertex, negative b over 2a. So we have negative b over 2 times our a value. We have negative 7. 2 times 1/2 is 1, so we get negative 7. Okay, that's going to be the h. Then we plug in negative 7 into the function. 1/2 negative 7 squared plus 7 times negative 7 plus 24. We square 7, that's 49, times 1/2 minus 49 plus 24. So I'm going to go ahead and combine these, and then I will worry about the fraction here. So when we have negative 49 and 24, that's going to be 25 plus 49 over 2. And to add this easily, I'm just going to make this be a fraction with a common denominator of 2. That's negative 50 plus our 49 halves. And of course, that gives us negative 1/2. And when we put that together, our a value is 1/2. We got that from here. And then we have x minus negative 7, so that's x plus 7, quantity squared, minus 1/2. Factor to vertex, again, we have to go to standard first. We're going to multiply. So this time I can just go ahead and multiply the understood negative 1. Okay, now we have standard form. Now we need to find the vertex to put it in vertex form. So we have negative b, so we have negative b over 2 times a. This is going to give us 4 over negative 2, which is negative 2. That's our h value. Then we plug that into our equation. We have negative, and then x is negative 2 squared minus 4 times negative 2 plus 12. Now, be really careful here. You do your exponent first. This is going to give us a positive 4 times the negative. So it's negative 4 plus 8 plus 12. This is going to give us 4 plus 12, 16. So when we put this together, let's write it here. F of x, our a value is negative 1. We have x minus negative 2, which becomes x plus 2, quantity squared, plus 16. Vertex to factored. So we are going to have to turn it to standard using order of operations, and then we will find the factors. Our a value is an understood 1, so we have x plus 4 times x plus 4, and then we subtract the 4 at the end. X squared plus 4x plus 4x plus 16 minus 4. So I have x squared plus 8x plus 16 minus 4. So standard form is going to be x squared plus 8x plus 12. Now we need to put it in factored form. We have a times c. 8 is the linear term. We are going to use 6 times 2. So factored form, our a value is 1, x plus 6, and x plus 2. So our two factors or roots are -6 and -2. The vertex, -4, -4. Our y-intercept, 0, 12. So with all three forms, we can see a lot of key features. Okay, let's try one more to go to vertex. From vertex to factored, we first have to go through standard. So our a is -1. So we're going to multiply the two binomials first, then multiply by the negative, and then add the 4n at the end. We have x squared minus 1x plus 1. Combine. And distribute the negative. And bring in the 4. So standard form looks like -x squared plus 2x. And then we have plus 3. We're going to find the two terms. So we have -1 times 3. We have 2 is our b value. And what can multiply to give you -3 and add to give you 2? Our a value is -1, and then we have x plus 3 and x minus 1 for factored form. Our two roots, -3 and 1. Our vertex, 1, 4. Our y-intercept, 0, 3. Our parabola turns down because our a is negative.